We are given that the line BC is parallel to line DA. That's the first line going across, and that is congruent to that line that is going on the bottom from left to right. Then we also know line BC is congruent to line DA. So besides the top line and the bottom line being parallel, they're also congruent. They're the same. We're trying to prove that ABC here is a parallelogram. So let's start with our just given information. Line BC is parallel to line AD, and line BC is congruent to line AD. We also see that there is a line that is the diagonal of this. So we know that line AC is congruent to line CA. That is just the recessive property. I gave it 3 marks here to indicate that the lines are congruent to each other. Then we can actually say that the angles here, BCA, is congruent to angle DAC. That is because of the parallel lines. So if the lines are parallel, then the alternate interior angles are always congruent. Okay, and I show that with those markings. Then as a result, we can say that the triangle of CDA is congruent to line CBA because we were given an angle, then a side and a side. So it's side, angle, side. Okay. Once we know that the triangles are congruent, then their individual parts are congruent. So we could say line AB is congruent to line CD by congruent parts, congruent triangles, CPCT. Then from there, we can say that the ABCD is a parallelogram just based on its definitions.